Hello and welcome. Today we are going to be talking about marine resources. And why do we care about marine resources? Well, we all use and benefit from resources that come from the ocean. And a lot of times we treat these resources as if they are infinite. And it turns out that a lot of these are actually limited. And with the exponential growth of the human population on Earth, we have to be careful that we are using these resources in a way that aren't destroying those resources and that they don't run out. All right, let's take a look at the four different types of marine resources. The first type is a physical resource, and this is when we are extracting some substance from the ocean water or the ocean seabed for our benefit. A lot of these are going to remind you of some of those sediments we discussed when we talk about earth materials. Example would be sand. Another example of a physical resource are fossil fuels such as oil. The next type of resource is energy. In this case, we're not actually removing a substance, but instead we are harnessing some of that abundant energy that we find in the ocean in the form of wind, waves, tides, stuff like that. So wind farms and wave power are examples of an energy resource. The next is a biological resource. And this is when we're actually removing marine organisms, mainly for human consumption. In other words, seafood. So that's things like fish and crustaceans. And then finally, the last category is non-extractive resources. And this is just using the ocean in place, where we're not removing anything, but we are acquiring some benefit from the ocean. And an example of that would be transportation and recreation. Okay, let's look at these four categories in a little bit more detail. As we're going through this lecture, let's keep two different terms in mind: renewable resources versus non-renewable resources. We've probably heard these terms before, but let's make sure we understand what they mean. A renewable resource is a resource that can be replenished by natural physical processes or growth of marine organisms. A good example is a wind farm. It's not like we're using up that wind by harnessing the energy. There's more wind coming behind it. Now, a non-renewable resource has a fixed amount, and this resource cannot be replenished over the course of human lifetimes. So, an example of that is oil and gas. This is a resource that takes millions of years to develop, and so once we use it up, it's going to be gone as far as we're concerned. Now, for a lot of these resources, you'll notice that depending on how we extract that resource, it might be in a way that is renewable or non-renewable. So there is some gray area here. Okay, let's start by looking over our physical resources. And we're going to start by looking first at mineral deposits. And this is a lot of the materials that we learned about when we learned about earth materials. And a lot of these are those hydrogenous sediments that come out of the ocean water. So this is material that has been dissolved in ocean water, and then we can extract that material by forcing it to precipitate, form a solid, or natural processes in the ocean cause those to form. So these manganese nodules that you're seeing in this picture, this is a metal that we use for industrial purposes. The salt that you put on your spaghetti at night, that is extracted from the ocean, along with potassium that might be in your supplements. And then finally, limestone, which is a building material or is used in your antacids, your Tums if your stomach is upset. These are all coming from the ocean. This is a picture of a salt evaporation pond in the San Francisco Bay Area. And so the way we extract salt from the ocean is a little bit like the way those inland seas work, that you have evaporation and it's leaving that salt behind. Now, The colors that you're seeing is actually algae growing in these salt evaporation pools. Now, I used to pass these ponds several times a week on the way, several times a week on the way to work. And one thing that the book doesn't smell you is that this area smells like absolute garbage. And even though it might look pretty, it smells horrific. Our next physical resource is oil and gas, our fossil fuels. Now, we're going to be hearing a lot more about oil and gas in the upcoming lectures when we talk about climate change, when we talk about ocean pollution. But let's first see where it comes from. We call them fossil fuels because it is actually made of the remains of ancient organisms. That's right, the gas that you're putting in your car that makes it go was once old plankton and bacteria that died in the ocean, sank to the bottom, and it accumulated at the ocean bottom and was buried by other sediments or other microscopic organisms. And so, with time, pressure, heat, uh, those organisms transform into the substance that we know as fossil fuels, oil and gas. And so that substance can get trapped in pockets of rock. And so in this image, what you're seeing is a geological structure called an anticline, and it traps that oil and gas under the layers of rock. And so for humans to use it, we have to drill down into that rock and pump it out through a well. Now, this is big business. This is the most valuable physical resource and probably the most valuable ocean marine resource overall. This is a non-renewable resource. It takes millions and millions of years for that plankton and bacteria to transform into oil and gas. So this isn't something that's going to be replenished in our lifetime. So in this image, we're just seeing a normal vertical well. And since this is not a renewable resource, a lot of these wells extract that oil and gas and then, for lack of better words, run dry. And so we've had to develop new techniques for extracting oil and gas because kind of that low-hanging fruit has all been used up by these vertical wells. And so next we're going to watch a quick video on something called fracking, which is a new technology that we are using to extract oil and gas. I'm going to pause here for a minute so you can watch the video just below this one in the list, and that's going to be on hydraulic fracturing.